Okay, sorry for getting snippy with you right there. When things don't go right, it's a mess, especially when there's 20 different things of technology we got to mess with. All right, getting back to where we're at. Here's a calendar. Chapter 4 deals with geometry. This is crazy a lot of vocabulary today, right? In order to do geometry, we got to start with the basics. The basics starts really simple, right? You can see this whole sheet is full of empty spaces. Whenever you see that many empty spaces, you know you're going to be doing some writing. You didn't get one? Okay. Whenever there's this much space, it's a lot. Geometry has lots and lots and lots and lots of vocabulary. All right, here we go. Your homework tonight shall be the following. Right there. Yes. Go for it. All right, most of this is just looking at a shape and naming something. Malachi, turn around, please. Most of this is just looking at a shape and naming it. Some of you might have some background knowledge. You know how to do this. Most of you do not. 7th grade is when we really get into actual geometry. What you've been doing up to now is you've been messing around with shapes just a little bit. All right, we good? Yes. Hurry up. Yes. Hurry up. All right, here we go. So the section's entitled Points, Lines, Planes. This is not the class to not pay attention to. It's mostly definitions. In fact, there's no calculations. We're not going to mess with numbers today, at least in the class at all. All right, so today's class is dealing with geometry. Geometry comes from, well, it's the word geometry. There's 2 words that make up the word geometry. Geo, meaning, it's from the Greek, meaning, absolutely not. We are standing on earth. Geo means earth in Greek. The earth they call geometry is from metric, and that means to measure. So geometry is the mathematics of measuring the earth, not literally the earth, but things that are on the earth. Ancient people could not really wrap their head around the fact that there were other worlds in space and whatnot, so they measured things on the earth. Today, lots and lots and lots and lots of vocabulary words. So you got to take good notes, and you got to understand the notes. Here we go. In box 1A, there are 4 boxes, right? In box 1. The long box is the definition. The small box is you draw the shape. Okay? You get it? All right.
What does red mean?
Red means take notes. This is not a shape. This is indicating a location. Right here is a location. There's nothing there, right? It is a location in space. In geometry, we talk about a location in space. We call it a point. We call it a point. Yes, most of the times we draw a circle. Points have no shape, no size. I could put a teddy bear right here to represent that location. Typically, we draw a circle. It could be a diamond. It could be an X. It could be anything, but we will stick to circles. Okay? Write this down. A point is just a location. It has no size. It has no shape. It has no thickness. It has nothing. There's nothing there. Yet if we got to talk about this nothing, why don't I see pencils moving? Thank you. If we got to talk about that location, we would like to visually see that location. Therefore, we have a representation of it, which is a circle. It could be a triangle. It could be a rectangle. We use circles. Okay. How do we name points?
Can we draw the point?
Yes. In the small box, make a point. How do we name points? Who knows? That's how we apply it to 2 dimensions, yes.
The X and
Okay, that's how we give it values. That's how we name its location. We name points with capital letters. We have 26 letters. Therefore, I can name 26 points. That's a problem. We run out of letters if we have more than 26 points. So in math, we will talk about it, not this year, but following years, of how we get around that.
Can you go like a capital A and then a lowercase?
Nope, no lowercase, only. Why don't I see pencils moving? In your small box, name your points. I named mine, I named mine A. Okay, you can choose any one of the 26 letters. The A, where does it go? Top, bottom, left, right, or does it matter? It does not matter. Okay? The A can go anywhere. The A can literally go right here. Well, that would be confusing because the point is over here. So if the letter A is way off to the side, you need an arrow pointing to it to indicate that's point 8. Like, why in the world would I ever do that? You'll see it in high school geometry.
Oh no.
Okay, we good on points? Yes.
How long will we take high school geometry?
Sophomore year. All right. Now we're going to talk about shapes that can be made with points. But wait a minute, you said points aren't actually there. Yeah, we're talking about a collection of locations. And if you play connect the dots, so to speak. All right, here we go. If I start off with 1 point and draw a second point and play connect the dots, what did I make? You absolutely did not make a line. I made what is called a line segment. Some books call it just plain segment. Our book says line segment. I'm more in the, let's call it pencils, move, let's go. I'm more of the camp that says, let's call it a segment. Our book calls it a line segment. It's part of a line, so it's not the whole line, it's just part of it. It's the part that connects the 2 points. Long box is the definition, small box, make a segment. Line segment according to our book. Okay, how do we name line segments?
You take the points that are
Which points?
A and B.
I take the 2 endpoints and
Combine them.
I combine them with one symbol that represents a line segment. Take a guess of what represents a line segment. Take a guess of what represents a line segment. 2 capital letters is the name of a specific line segment. Guess what symbol represents a line segment? A line would represent a line. What would represent a line segment? Okay. How about a line segment? So we name a line segment by its 2 endpoints and we put a line segment over the top of it. That's the symbol for line segment. That's what will differentiate it between a ray and a line. Yes. The long box is the definition right here. The small box is the give me a line segment and name it. Yeah, write a little bit smaller. It's a pretty big box. Come on. So we have a conundrum. Do we have to name it left or right? Could we name it right to left, or does it make a difference?
It makes a difference.
What difference would it make? I call that BA. Is that not the same line segment? What's different about it? Okay, so if I drew BA, would it be any different than what you see right there?
No.
If I started with B and went to A, would it make any difference? So therefore, we have options with line segments. We could also call this BA. It is your choice. If you always want to go left or right, go with it. But what happens if it's up and down? What happens if diagonal? How do you name it? It's the 2 endpoints. Leave it at that. So there will be 2 options to name line segments. How many points are on this segment? Think about that question.
2.
You want to agree or disagree with her? You want to agree or want to disagree with that? She said infinite. How many points make up a line segment?
2.
If they make 2 points, then how did you play connect the dots? You connected the dots by connecting other points that are on this particular geometry. Therefore, how many points are in a line segment? Infinite. Hey, there must be a point right there, correct? Is it on the segment?
No,
How is it not on the segment?
because we don't have a dot there.
I just put a dot there.
Well, it's on your slideshow.
Oh, that's the name of this segment. But would you agree that there's a point right here?
Yes.
Well, give it a name.
C.
So is C on line segment AB?
Yes.
Absolutely. So could we name this segment, the entire one, could we name it AC now?
You can name it
No.
AC.
No.
and then
Why not?
CA.
Because you have to do it from the first point to the last.
I have to name it from the first point to, then we call it the two endpoints. So even though there are an infinite number of points between A and B, we can't choose any of the points between A and B if we're talking about the whole darn thing. You got to tell me, are you paying attention?
Yes.
Does that make sense?
Yes.
Jaden, I'm pretty sure you're not paying attention. Okay. This is a test question right here. I will say, is this line segment AC? If we're talking about the big thing, and your answer is going to be
No.
no, absolutely not. Is there a segment AC though? Yeah. Absolutely, positively. Hey, it goes from A to C or from C to A, depending on how you want to think about it.
And then C to B.
And then C to B. So there's actually lots of segments here. All right, so here's that example a little bit nicer. Okay, what line segment is there, or is that a challenging question?
X what?
X, Y.
X.
That's a challenging question.
X.
X, Z.
If I say name the segment, you need to ask me
Which one?
which one. How many actual segments are up there?
Three.
Three.
I hear 3 and 2. Which one?
Two.
Who wants to argue there's only 2? Which 2 do you see?
I see X, Y.
Okay, he sees this one and this one. Those are the only 2 segments up there. Who's arguing 3?
I see X, Z. The
Oh, and then you got the long one. There are 3 different length segments right there. So when I say name the segment, you got to come back with a which one do you want. If I say name the shortest segment, what do you say?
X,
Y.
Or
Y.
ZY is longer than XY, so you could also say YX. If I say name the medium one, you would say,
Y.
or, and if I say name the long one,
X, Z, and ZX.
don't you love geometry?
Yes.
Right? Geometry, very rarely do you mess around with numbers, sort of, I'm exaggerating slightly. But geometry is just looking at a shape and talking about it. All right. Although, ironically or paradoxically, the name geometry means to measure. So eventually we will get to measuring. All right, 1C. The next shape starts with a point and goes in one direction forever. In other words, it's a crappy boy band. What do we call this shape? If you start with an endpoint and go in one direction forever, we call that a ray. Okay, hurry up. So a ray is a geometric shape. Right, people, come on, let's go. You guys are like really doing bad today. Well, not all of you. Some of you are doing great. Some of you are like sitting there like, are these going to make me right again? Yes, I am. So a ray is a part of a line. Hey, a segment was part of a line, so is a ray. A ray is part of the line that starts with an endpoint and goes in one direction forever. Doesn't ever stop. That's the difference between a segment and a ray. The ray never stops, but it only goes in one direction.
One direction.
Point.
That means a ray is better than one direction.
Exactly.
It doesn't end.
And it didn't take much then, did it? To be better than one direction.
Imagine if you were to able to go to.
All right, right?
I'm done right.
All right. How do we name a ray? Think about that. How do we name a ray?
A to infinity and beyond.
What do you got?
Maybe like A, B, and then like a line over it with an arrow.
A to plus.
In other words, not a line over the top.
A ray.
That's how we name. Now be careful. Rays you can make mistakes on. Rays must start with
An endpoint.
Which end? Well, it only has one endpoint, so it must start. The B is not the endpoint.
The B is just
The B is a point along that one direction. Okay? A is the only endpoint on the ray. It doesn't go any further to the left after A. So we name rays starting with the endpoint and then any point. Hey, I only labeled one. But remember, there's an infinite number of points here. I can name that. I can name that C. So guess what? AC is the same as AB. This is only for rays. AC would be the same as AB. Why? Because it continues on. It doesn't stop. So you have to start with that. The arrow, guess which direction it has to point?
one direction.
Well, what happens if the ray points straight up? Then you don't want to have a symbol pointing straight up. So
Yes, you do.
on the label itself, the ray will always point to the right. I'm talking about the label, the bottom thing, AB. It will always point to the right. Your ray, actual ray, can point in any direction. Okay?
Up, down, side, side.
So this is only AB. We cannot name it ray BA. Why? Because it doesn't go from B to A. It goes from A in the direction of B forever. You may also use the words ray AB. Yes.
You say array, so like a.
I'm not saying array. I'm saying RAY.
Oh, because it sounds like it.
Well, if you have to put the words, if you have singular a ray, then you have to use the word a space 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 ray. An array is something else, and that is high level math. They're arrays.
Arrays we learned in like second grade. It's very simple.
I was going to draw you an array and ask you to add them.
Wait.
Okay,
you
I'll
draw
do it.
the
I'll do it.
array?
Not right now. It's Friday. I don't have much time. All right, moving on. Here is a ray. What's the name of this ray? Could I call this array AB? Notice that inside every ray is, guess what? A segment. So even though I have segment AB or BA here, if I want to name the ray, then I have to go BA. I cannot say AB, right? I cannot say BA.
Why did you put the arrow going that way?
Because the issue is not because I couldn't put it going to the left, but what happens if the ray points up or at a right angle, or I'm sorry, at an angle, diagonally? We don't want to change the naming thing. So you can't tell which way the ray points by looking at its name, but you can tell where it starts and where it's going. It's going from B to A. Does that make sense? Okay. All right. How many rays are here?
One. There's 3 segments.
There are 3 segments. How many rays are there?
One.
There's 2 rays.
What? Wait, there's C to B and B to A.
Okay. Here are the 2 rays. Where's the one that you see?
C.
C, and that goes in this direction forever, never stops. So there's another ray there.
B? No, A.
If we start at B and we go in this direction, notice it doesn't have this part of it. There are 2 different rays there. There's ray CA, or you could call it CB, either one's fine. And then there's ray BA, 2 different lengths rays, yeah. Well, A is just a point. So if there was another point over here, agree, A, D or something like that would work as well too. But just from those 3 points that are labeled, there's 2 different rays, yes. CB, yeah, there's 3 different line segments, sure, certainly. CB, BA, and AC, absolutely. Okay. BC is the same as CB. All right. We can't say that there's ray AB though, because it stops right here. And remember, rays have to go forever. All right, so these 2 rays are the same.
Wait, why
This, what?
why is C B array? Shouldn't it be A B is array?
Well, if I start with CB and it's a ray, doesn't it go forever in that direction? It would include A, even though I could name it CB. So these 2 right here are exactly the same ray. This one's different. It starts at B and goes to the left. Both of these start with C and go to the left.
There's 3 rays.
There's 2 rays. This is the same ray in yellow. It's the same ray. It starts at C and just goes left. It starts with C and goes left. I'm just choosing for the second point to use D on one of them and A on the other one, but it still goes left forever. We okay with that? All right. Last one. This is the hardest one. Oh, wait. Sorry. Wrong one. All right. 2 points, and now not go in one direction, but go in
That direction.
both directions. We say opposite directions. That's called a, write that down. Lines.
That's it.
It's the infinite series of points that extend in opposite directions. Opposite directions. How do we name lines? How do we name lines?
You take your points, put together, and have a line.
How many points do I need to define a line? Just 2. You can choose any 2 points on the line. It doesn't matter. It matters for segments. It matters for rays, lines. Easiest one. Just pick 2 points on the line. Put a line over the top, and oh wait, there's a third letter here. Now we make things complicated. Look at the board. Because it can get really messy in geometry. I mean, like drawing the shapes can get messy. Occasionally, you will see a lowercase italicized letter floating around the line. It's a second method of naming a line. Right? Notice there's no dot here next to the lowercase italicized n. Geometers said a long time ago, hey, we need another way of naming lines. Our diagrams are too messy. So they came up with this method. N is not on the line anywhere. It's just like it's spread, right? Except they didn't want to put 5 letters. They just wanted to put 1 letter. So they decided this is what we're going to do. It is very arbitrary. Okay. So you may also call this line N. You will see in our chapter occasionally when they have a line, there'll be a lowercase letter just next to it. It's not a point. It's just the name of the line. It's not that you got to name it 3 different ways, but you have options. When we get to geometry in high school, almost always we name lines by lowercase letters because our diagrams are really messy. Who's lost? So, unlike Jaden, who almost has it done right? You should have it all filled out. Yes?
Yes, sir.
Okay, tonight for homework, they're going to show you shape. You got to name it. But they're going to make it complicated. We ready? All right. What do you see here?
G and R.
A line.
A line.
I see everything that you wrote in box number 1. I see points. I see segments. I see rays. And I see a line. You got everything. Tonight for homework, they're going to say, state what this is. Well, that's a pretty open-ended question. Well, there's 2 points. There's 1 segment. There's 2 rays. What 2 rays?
G and R. G.
Those are opposite rays, right? And then you have line GR. So you got everything from box 1. So certainly there's line GR, but there's also segment GR. There's ray RG, ray GR, and points G and R. It gets even more complicated if they drop another point there. Now we have 3 points. We have 3 different segments. We got 4 rays.
What?
1, 2, 3, 4. How many lines we got there? We only have 1 line. Line is the easiest one. Okay.
Can we just do lines?
Boy, wouldn't that be nice? All right. So you got lots of stuff here. Lots of stuff here. Oh, by the way, how many lines am I naming here? Sure looks like 6. How many lines are there?
One.
There's only 1 line. These are all the names of the same line. Why? Because it goes on forever. It doesn't stop. So even though you call it line BC, well, it goes to the left forever, so it would include point A. These all name the same line. All right, so here's your first picture of a complicated picture. All right,
What the heck?
so this is a combination of a line and a ray. Combination of a line and a ray. Stay with me. Okay, you can name lots of things going on here. If I ask you to name the points, that's easy. What are the points up there? A, B, C, D. If I ask you to name the segments, well, it's going to take some time. Clearly, there's CD, but there's also BC. There's also BD, and then there's AC. There's lots of them. There's what? No, there's no AB. Unless I force it to be connected. T is the line T. So naming a line, we could say line T. Is there a line AC here?
No, it's just
No line AC. Why? Because it stops right here.
T. There is a BD.
There is a, well, now you got 6 different ways of naming 7, including T.
It's just
So there's lots of different ways to name that one line. There's only, well, there's lots of rays here as well, too. Yes?
If this is on the homework, they need you to name everything.
They're going to tell you what to name. They're going to say name the rays or name the segments. Okay, it will tell you. All right. Okay, we'll just do an easy one. Oh, by the way, this is a
triangle. Triangle.
It is an angle for certain. We're going to talk about angles on Monday. All right, here we go. So name the points that you see. This is box 2. What points you see? C and B. Name the segments.
NB
And C.
Oh, that was easy. There's only 2 of them. Yes?
Yes.
If you're sitting there doing nothing instead of writing, you are wrong. We're on box 2. Write the answers. What rays do you see? What rays do you see? If you said you see ray CN, you are wrong. Why? It doesn't go in that direction. It stops at point N. So there are rays NC and ray NV. Yes? Yes.
I think we're ready for
What are we naming? What are we naming? Now, what are we naming?
Points.
Points. Oh, so the only points you see are V, comma, N, comma, C. You don't have to put the word points. Good question. We okay?
Yep.
All right.
Whoa.
I'm going to skip box 3. Notice it gets even more complicated when they add more stuff.
What the
All right.
heck?
Box 4, look at me. This is a flat surface, yes?
Yes.
Imagine a flat surface that goes on forever. That means it goes, watch me.
That's a plane.
Listen. Goes to in that direction forever. It goes in that direction forever. This direction, that doesn't go up or down. This is called a,
Whiteboard.
this is called a flat surface. In geometry, when we talk about a flat surface, well, we got 2 problems. One, you got to be able to wrap your head around it. Can you wrap your head around a flat surface?
Nope. Yes.
But it goes on forever.
I can wrap my head around that.
Okay, now stay with me and be serious for a second. Well, how do you draw this?
You don't.
You don't.
You can't because it goes on forever. But wait a minute. We drew a line and it goes on forever. So in geometry, we have a problem. Your book is in 2 dimensions, left, right, up, and down. This whiteboard is in 2 dimensions, left, right, up, and down. But in real life, this is real life. This is in 3 dimensions. How do you draw this? You're seeing it right here. You see this blue, and it's almost always blue. Don't know why. Do you see this shape? We don't know what it is yet. I'll explain it. It's not a trapezoid. You see this shape?
That's a parallel.
When you see this shape right here, they are claiming that this is the concept of a flat surface that goes on forever. It is called a,
Parallel.
it is called a plane.
Aeroplane.
It is called a plane. A plane is a flat surface. Now, this is a troublesome description in all directions. It means the flat surface continues. Right, for the love of God. Right. If I need to motivate you to write these things down, I will. Okay. Flat surface extends in all directions. Yes.
I have a question on 2 for the example.
Yes.
So like for the segments, since it was like
NVCV, CN, sorry. That's it.
so would CV be one, or is it not able to go?
It's not showing that they're connected. Could we create segment CV? Absolutely positive. but it's not shown in the diagram. Okay, so this is an imaginary shape. It does not exist. But in order for us to talk about the plane, we got to draw something, just like points don't exist. But we draw a shape to represent it. Okay, so there is your plane. Has no thickness. Now, since we actually draw it in the shape, it's got corners, but it doesn't really have corners. Okay, this is a troublesome concept. It looks like it has corners. Therefore, we name those corners having points. They don't exist. They're not there. But yet we draw it this way. So when you see a plane, they're going to label the corners. You just have to make sure you understand there are no corners in planes. It goes on forever. It doesn't stop. Sometimes planes will have once again, a letter in a corner that doesn't apply to the corner. It's just kind of floating there. And that's how we name planes. All right, last thing is this. If I have a plane, and on the plane itself, I draw two intersecting lines. Yes?
Yes.
That's what they're trying to show there. How many places can two lines intersect at?
One.
You want to argue more than one?
No.
They can argue and then they can.
How's the only way you get two lines to intersect in more than one spot?
You can go
How could you make it?
multiple lines.
Two lines.
Two lines.
Zigzag.
You would have to take one line and curve it around. Hey, guess what we named that shape? A curve.
Upside down next.
Okay,
Upside
it's
down
not a
V.
line. The only way you get two lines to intersect in more than one spot is if one of them isn't a line. Lines go in opposite directions. They don't curve. They're straight, as we say. We don't say straight line because that's part of the definition of line. So, how many places do two lines intersect? One spot. Okay? That is called an intersection point or intersecting lines. Box 5A. We're about to run out of time. So as you're copying this down, I want you to look at me. I didn't say back up. Sit. What's the opposite of intersecting lines?
Not in.
Parallel line.
Look at me. You're going to have to, over the weekend, open your book and write this down. When two lines do not intersect, they could be.
Parallel.
Why did I say could be? There's one other construction. This is brand new. Look at me and pay attention. Two lines either intersect. Can you imagine that?
Yes.
Or they are, there's one other exception. You ready for it?
Yeah.
What's that?
A cross.
No. A plane.
Do these intersect?
No.
Are they parallel? Stop and listen. Do they intersect?
No.
Are they parallel?
No.
We need a name.
Not parallel or
Write this down. Write this down somewhere. This is called SKEW. Skew.
skewer.
These lines are skew. SKEW. Those are, now we've got to write the definition. These are lines that, tell me what's going on here. They don't intersect and they are not parallel. Good job. Parallel lines intersecting, skew. Now they don't have to be like right. This is skew as well too. They're just not intersecting and they're not parallel. All right. You may have to do a little bit of thumbing through the section to answer some of your homework, but we covered majority of it. Have a good weekend.
You too.
All right, e-learners, I didn't get through all of the slides. However, I got through enough to help you. I do want to show you guys a picture of parallel. There's parallel lines. And then since you couldn't see my demonstration, I want to show you skew lines. So skew lines are when two lines are in separate parallels or separate planes. They do not intersect and they are not parallel. Can you see the picture here? That's what skew lines are. All right. Have a good weekend and I'll see you guys next week.